Have you ever thought that how are astronauts breathing in the space station? How are they continuously sustaining those harsh conditions? Well, as you all know, that when we breathe, we take in oxygen while during exhaling, carbon dioxide is released, which is a very harmful pollutant if it continues to accumulate in an enclosed environment such as space station. So currently, NASA is removing that exhaled carbon dioxide using an absorption-based system called Carbon Dioxide Removal Assembly or CDR as mentioned in the figure. Though NASA is maintaining a very safe environment for its people, but is the system simple, risk free, cost effective, and sustainable? The answer is no. And the reasons are the objective of this thesis. And here we are proposing a different adsorbent called aminosilica as compared to currently used 5S zeolite. So currently NASA is removing water and carbon dioxide from the exhaled gases in two separate vessels because of the hydrophilic nature of zeolite 5A, referring to additional capital cost as well as higher risk because of downtime. Whereas in aminosilica, both water and carbon dioxide can be removed simultaneously. Now, for any adsorbent, activation and regeneration are the two most important parameters as they revive the initial adsorption capacity. Like silica gel in your newly bought pair of shoes, most of the solvents love water. So, whenever any adsorbent is exposed to a wet gas mixture, they tend to absorb water. And here activation comes into play. Now, the absorption or activation condition required by 5-way zeolite are far severe as compared to aminosilica. Again, the CO2 uptake on both the solvents is nearly the same, but the difference is created by regeneration. And again, 5 zeolite requires far severe temperature conditions as compared to aminosilica. Now let's discuss sustainability. What is the sustainable development? It focuses on reducing the environmental impact of any process, transforming a linear system into a closed loop process, reducing waste generation. Now, the question here is, do we just want to remove the exhaled carbon dioxide to make the habitat safer, or do we want to reuse it? And can we do that? The answer here is again no for 5-SU. This is because, along with the carbon dioxide, it tends to absorb nitrogen and oxygen present in the regeneration media. Now, if you want to reuse that carbon dioxide, you have to add an additional separation technique. Whereas for aminosilica, pure carbon dioxide can be obtained because it has no affinity for neither nitrogen or oxygen. So overall, though NASA is making heaps of progress, but one of the most essential system is neither cost effective nor sustainable or risk free. Thank you.